to find the determinant of the Hessian of a function, you need to know how to do partial derivatives and how to find the determinant of a 2 by 2 matrix. If you don't know how to do either of those, if you head to the description below, there is links to videos that I've made on both of those topics. The Hessian is the determinant of a matrix like this. So h, f, x, y would be d squared f over dx squared, d squared f over dx dy, d squared f over dy dx, and then d squared f over dy squared. You would then find out the determinant of this is by doing this times this minus this times this. So let's start figuring out what this is, and this is. So d squared f over dx squared would be this differentiated in terms of x, so all the y positions are hold constant and we would just ignore them. If you don't know how to do partial derivatives, please go and watch another video because it's going to take too long for me to go through all the partial derivatives fully. So this differentiated twice would be 2y sine h x plus 2y plus xy cosh x plus 2y. Let's now do d squared f over dy squared. So we're now going to differentiate this, holding the x terms constant, and just differentiating through all the y terms. So that's going to be 4x sine h x plus 2y plus 4xy cosh x plus 2y. And now finally, we're going to do d squared f over dx dy. To do this, you would then take 1 df over dx, you'd have that value, and you would then do the partial derivative of that in terms of y. So you will get cosh x plus 2y, 1 plus 2xy, plus, I'll do it down here, plus sine h x plus 2y, 2y plus x. You need to be very good at partial derivatives and be as careful as you possibly can to make sure that each of these are completely correct. Let's now start substituting in values. This looks all pretty complicated and we've got a bunch of different sine h's and coshes, so let's try and solve that first. So if we take sine h and we plug in the values for 1 and minus a half, you're going to get 1 plus 2 minus a half. That's going to equal 0. Cosh 1 plus 2 minus a half is going to equal 1. So that certainly simplifies out a lot of this. So if we now take d squared f over dx squared, and we've substituted in a value for 1 and minus a half because it's at this point, that's all going to equal 0. So you're then going to get 1 minus a half, cosh x plus 2y with that added in is going to be 1. So therefore, that's going to be minus a half. Let's now do d squared f over dy squared. We have here, we know that sine h is 0, so that's going to be all 0, because 0 times 4x is 0. And then we'll have 4x, which is 1, y, which is minus a half, and then cosh, with that all substituted in, is 1. So therefore, the answer to this is minus 2, if we simplify that out. And then let's now do d squared f dyx. And once we plug in all the values here, obviously our sine h disappears because it's all 0. Cosh x plus 2y is 1, and then we'll have 1 plus 2, and then x is 1 and minus a half. And this, once simplified, equals 0. We're now in the position where we can, we've got all of these values and we can plug it into this Hessian. So our Hessian, we're at the point of 1 and minus a half, is going to be minus a half, minus 2, 0, 0. We know that the determinant of A is going to be AD minus BC, where A, B, C, D. So these two minus these two. So let's do that. Minus a half, minus 2, minus 0. Obviously, that's unnecessary. Minus 2 times a half is 1. So now we know that the determinant of the Hessian of this matrix at the point 1 minus a half equals 1. Yeah, so we did it.